I'm going to first ask the panelists to come up. They'll take their seats. Then I'm going to ask each of them that first question, really, just to see what they think about what I just said. And they, and this is as I mentioned, a distinguished panel with a lot of different opinions, I think. And I think managing it is going to be a challenge, but I look forward to that. So let me invite the panelists up. Lior Frankel, and then I'll give them an opportunity to introduce themselves when they get up there. Xavier Mesrobian, Dale Peterson, somebody else. Again, that's a joke. It's Albert Roy Akers, I'm sorry, and Rich Carpenter. Okay? And by the way, you guys can thank me. I got you all water.
Thank you.
Because I was getting very thirsty in the last session, and there was no water. So. Okay, so just as I mentioned as a kickoff for this, let me ask each of you, just go down the line here, but you just saw my comments, but I'd like to get your view of the industrial Internet of Things, or whatever you think the future of cybersecurity challenges are. I don't want to make it so you're here for half an hour talking about that, but relative to what I just said, your views of it, maybe I'm way off base or not, but anyhow, to do that and at the same time tell the audience, a few things about yourself and your company and what you do and things like that. So, Rich?
Sure. All right, I guess I'll start. So I'm Rich Carpenter. And
are these on? Is that on? Okay.
I think so. You hear me okay? Peter Lunk was supposed to be here. He apologizes he wasn't able to make it. He's with our World Tech division. I'm actually Rich Carpenter. I'm with the Intelligent Platforms division of GE. And we make a lot of the industrial software and the control systems that are used in many of our applications. So, GE embarked a couple of years ago on the industrial internet journey, and we're pretty much all in. It's more than $1 billion investment ahead of the curve from within GE, and it's sort of based on the premise that, to support the $220 billion worth of backlog that we have for our equipment in the field, that we need to be able to connect to it, we need to be able to bring that data back to a central location, we need to be able to analyze it and provide a better service as a result of that to our customers. And, we're clear that there's a large cybersecurity challenge there, both in terms of data privacy and in terms of the various threats that can attack various customer sites. And so we absolutely believe that you need to design the cybersecurity infrastructure from the ground up into the control systems, through the SCADA systems, and into the connectivity to the cloud. But we think it's inevitable that it's going that way because the cost to serve is a much better equation when you look at the cloud architectures from an elastic compute and storage standpoint. And more you can move faster and provide what I would call fleet level analytics in that infrastructure that you couldn't do locally. So we absolutely see that it's critical and that it's coming, and it's a big part of the GE initiatives.
Xavier?
Hi, I'm Xavier Mesrobian. I'm with Skynet. I'm the VP of Marketing and Sales. I would tell you that our position for the Internet, or the Internet of Industrial Things, for us started 4 years ago. Our founders have a deep root in Japan, and when they had the disaster in Fukushima, they had absolutely no idea why they didn't have remote access to that plant. And more importantly, why the hundreds of people walking around in the facility had these Geiger counters and they couldn't report the real-time data. Our basis is Cogent Real-Time Data Systems. Many of you may know us as Cogent Data Hub. We've been around for 19 years, and it's been really the focus of our team to develop a solution for the Internet of Things. And I will tell you, 3.5 years, 6 months of piloting, we finally released a platform which is a full end-to-end secure solution for connecting and networking any plants, any devices, secured by design, that keeps all firewall ports closed, or I should say out or inbound firewall ports closed, doesn't require a VPN, doesn't require any programming, and plug and play to any HMI or any SCADA system. So, when you say how committed are we bet the farm. We're there. We believe we have a great solution. We just launched it 10 days ago for public consumption, and the signups are consistent every day. Thank you.
Hello, my name is Lior Frankel. I'm the co-founder and CEO of Waterfall Security Solutions. Our roots are related to Sid's presentation in the classic IT/OT integration area, securing that integration, or in a sense enabling it in a secure way. And in recent years, we evolved and expanded also to other areas in this really exciting area of cloud services and Internet of Things. We have developed some new technologies based on our experience in securing mission-critical environments. And we have, by the way, a booth down there if you would like to see more information later on.
Good afternoon. I'm Dale Peterson with Digital Bond. We approach this issue and see this issue from a lot of different standpoints. Our consulting group works with owner-operators. Our labs actually test a lot of these vendor products, and then we, in our S4 conference, we work with kind of the bleeding-edge researchers or hackers, if you will, who are trying to break these things and publishing their results. So we see a lot of different points of view. The industrial Internet of Things is really hard to talk about generically because there's use cases, as Sid was talking about, or a taxonomy that we need to develop, and the impact on industrial cybersecurity varies quite a bit by that. We released some research in January showing how the progressive snapshot dongle, basically part of the industrial Internet of Things, could allow access to a car's CAN bus because it was insecure by design. It basically had no security. That's one aspect, and I think it was on the chart where you show customer or partner developed devices that are managed from a plant. Probably the most prevalent example in our host's documents has to do with sending industrial or control system or plant data out to the cloud for analysis for maintenance purposes, or perhaps to improve efficiency. And I think actually, if done properly, the impact of the industrial Internet of Things for that very important application is minor. It shouldn't affect the integrity or availability of the plant, and really you just need to worry about the confidentiality of that data. So in that case, I would say your major change or your major impact of the industrial Internet of Things would be confidentiality. But the key is, I think we need to start thinking about this as use cases or taxonomy and start to answer this question a little more granularly.
My name's Albert Roy-Akers with Bedrock. I spent 16 years in the process control industry, Foxborough and Vensa Schneider, and did a major refresh with the IA series in the late 90s, and then I went to Silicon Valley to get into semiconductor industry for about 14 years or so, and decided to start this company called Bedrock, and start with a blank sheet of paper and try to bring the latest technologies to the control system domain so that it could start to ride the wave of Moore's Law and other things. So we started with a blank sheet of paper just a few years ago, and we have some stuff over here. So hopefully some of you or all of you can come take a look at it. But I wasn't really thinking about security as the concept of the industrial Internet of Things. I was just thinking of security relative to ICS. And are we allowed to just sort of respond to some of these things at the same time?
Please, yes.
So how much time? Can I just take the next hour or so? And
No.
No? You sure?
No.
Okay.
Yes, I'm sure.
Okay. Anyway, so the ICS and IoT is whatever. I don't get it, kind of, because I think that a control system is a thing, right? So everything, which is really, it's an embedded device, should be secure. So what does that mean? It means that you actually have to start at the deepest layer within the technology, which is at the transistor level. So relatively new technology, was driven by the financial transaction markets for embedded mobile financial transaction, but secure microtechnology, microcontrollers were developed, and they've progressed a lot. So you can't build a secure device, regardless of what it does. If it's an embedded computing device and it's not using embedded secure microcontroller technology, it's an oxymoron. You can't get there from here. So a secure microcontroller is very different than a standard microcontroller, and I don't want to, blabble you with details, but it's a very, very sophisticated submicron device that provides anti-tamper technology at the submicron layer. So that's the first thing that's required in order to build a secure device, whether it's the Internet of Things or it's an ICS, which is a combination of things that connect, embedded devices, I/O cards, controllers, and other things that connect ultimately into the cloud or the internet in some way. So that's where you start. The deeper the root of trust is, the more success you will have. And so when you design a secure product, a couple of questions you ask is, how valuable is the asset? Who is your attacker? And what are the consequences of being compromised? So the advantage/disadvantage risk-reward of the industrial segment is that all of the assets are valuable. They're machines, they're things that blow up, they're transmitters, they're valves that cost thousands of dollars. They're not a thermostat or a window sensor in your house. So that's good. So you should spend some money on it. Second thing is, your attacker is sadly most likely someone that really wants to steal your assets or cause damage, like a nation state. So that's the other corner case. And then the consequences, they speak for themselves when things blow up and damage to property, but most importantly, damage to humans and human life. So the great thing is you can take a very serious approach with this. Now, some of you may have read Bill Leiden's recent article on emerging trends. If you start with a blank sheet of paper, you also get to address some other fundamental things like EMP. And I haven't seen this conversation very much because EMP can be a far more dramatic and catastrophic attack than a cyber attack, because an EMP pulse will destroy everything. And I wouldn't want 3 or 4 or 5 years from now to start to answer this cyber IoT problem. Then we're all sitting in a room trying to figure out how to solve the EMP problem, because the game's always going to change. Someone's always going to want to eat your lunch or cause damage. So EMP should be on the table. So you're going to solve the cyber problem, the EMP problem, and you're going to spend some money on it. Then you can do it in a very serious way. And the products start to look a little bit different. And the other thing is that once you do it right, although it's a new class of embedded engineers, they're new software engineers, they're crypto engineers, they're new hardware approaches. Once you get it done, once you figure it out, you shouldn't pay a cost premium for it. So when you come and take a look at the stuff, and I'll show you some stuff, some things, they're all here. It's all real, and we've built it. But it looks like several people have asked us, well, wow, what's the price premium for this? Well, it isn't. It's PLC DCS prices. Once you figure out how to do it right, it's not a cost premium. You just have to change the way things get thought and the way things get built. So that's it.
No, all right, and you really kind of started on my next question, but that's fine. I said you could. Okay. But since we've started on my next question, the thing I was going to focus on then was just ask the panel, what's a secure device, what's secure communications, and kind of work down through those elements that I mentioned. So, Dell, do you want to, do you all know Dell? I love Dell's blog, by the way, Digital Bond blog, but for years he's been writing about we need secure by design, quit being an apologist, right?
Well, a little bit. I guess a little twist on that is I wish the problem we had was that our systems were not secure by design, but actually what we run into is they are actually insecure by design. meaning you don't need to find a vulnerability, you don't need to find a coding error. You can use the features and functions in the protocols documented in the system to attack it. So your quote hacker, the hacking of control systems is actually the easiest part of it because you actually don't need to hack anything. You just use what's already there. Getting to secure by design is a lot harder than removing insecure by design. And you can very quickly determine if a vendor has done anything because that falls out pretty quickly. But what we usually look at is we talk to the vendor a little bit about their security development life cycle. So Microsoft wrote the book on this literally, and do they have a threat model? Do they have secure coding practices? Are they doing fuzz testing? Do they have an internal or external third party look at this? And you don't actually have to look at all the data and understand everything they mean, but just looking at their security development life cycle and how they've progressed through that can give you an idea of at least if they have a chance of being secure by design. And we're seeing, especially in the devices that don't look like computers, that aren't typically in plants, that whole philosophy of even worrying at all about security is kind of the same thing that happened with PLCs and RTUs years ago and other smart instruments. They just didn't even consider security at all. So it is going to be a major problem for those things.
Lior, would you like to comment? We can come back down this way, that's fine.
Sure.
Whoever wants to comment.
You know, the product that Bedrock is doing is, in my opinion, amazing. Okay, I don't have share in their company yet, but I think that if you are looking at a, you know, like a cost performance or where to put your efforts first, I think that the main problem today is the design of the systems, the integration of all the products to one solution. So there's something wrong here. And I'm hearing a feedback.
Can you turn down the gain or something?
You can have a...
No, he's over there.
What?
The man that's controlling the mics is over there. Okay. Go ahead, speak into it.
Okay. This is a cyber attack.
Is it better now?
Yeah.
I didn't know what the problem
Okay.
was, but
So you know, you can have great products that are fully secure, but if you put them in the wrong way at a solution, at a system integration point of view, your overall system will be vulnerable, even if each and every product by itself is secure. Because a product isn't standalone. It's part of a solution. It's part of a process. And I think as Dale said, I think that most of the systems today, when they were designed, not the devices, not a specific product, but when you come in and design a solution for a plant, design a solution for a specific a need, security isn't part of it, or in many cases wasn't part of it. And fixing that is easier, can be done in many cases with external solutions, with solutions that augment existing systems, and can add much more to the overall security than retrofitting all the products with new and more secure products by themselves. And another perspective for that is, again, if you're taking an attacker for a, attacking an industrial site, the main target of an attack is to have an effect or have a remote control ability to affect the process, the physical process that's running in the control network. They don't really care about a specific product. You know, if there is one product which is secure, so they'll find a way to hack through another one. If the overall security is sound, the attack, the level of attack becomes really complex, and that's what I think the overall goal needs to be. So you can have a really good product, really secure, but you allow it to be remotely controlled by a vendor because that's what you do. So, we won't attack the product, we'll attack your vendor. And get through the process that you allowed him to do to remotely control your site. It's an approved process. Your ultra secure product can be remotely secure because can be remotely controlled. So, we'll go through that path.
Xavier?
Well, I'm going to go about this a little different. How many people here have a Nest thermostat? Put your hands up. Come on, don't be afraid. Only one?
I don't, but.
Two. Okay, great. So here's the difference between something that's secured by design and something that isn't. For those of you who didn't know, the Nest thermostat actually contains your name, your address, your credit card information, and that information is not encrypted. I don't even need to take control of your house. I just need to take control of the thermostat, which, by the way, is clearly not secured. So, when you get home, you might want to take out your credit card because somebody eventually will get it. And this is well posted. I learned this a couple of weeks ago. I mean, one of the key things about secured by design, if somebody were to say, what does that mean? Well, I look at it really simply. As a child, if I was walking through school, if you wanted to prevent the bully from, taking your lunch money, make yourself invisible. That's the first thing. Invisibility cloak, if you could find one, would be great. But in the world of the Internet of Things, what it really comes down to is, A, security needs to be your top priority. It is the priority that you need to put above all else. You don't solve a business need until you solve security first. And from that perspective, I would say, for any device, you need to keep all your ports closed. No inbound firewall ports. How many people here have a VPN to their process control system? Anybody want to admit and put their hands up? Great. Did you all know that that is actually an attack surface on your plant? Of course. Do you have a proxy? Okay.
Yeah, people don't divulge that information.
Right.
do
We don't
so they
need.
can't.
And while you're at it, I'm just going to check your badge. We'll just no. Anyways,
He's spear fishing.
yeah, I'm spear fishing. At the end of the day, we want to just protect the fact that you want to keep the plant secure, and the best way to keep a plant secure is to keep your firewalls closed. So we have technology today to do that. The same thing applies with any connected device, any connected plant, any remote facility. We don't need to have VPN access into our plants. What we need is access to the data. So focus on the problem and don't circumvent security. And if you can do that, then you can build a secure by design solution as long as you remember that security is at the top and not a silo.
Great. I mean, I agree with many of those points, Xavier. I think some good ones there. I think you really have to consider the fact that control systems, independent of the Internet of Things, have many different attack vectors associated with them. When you add on the Internet of Things and the potential to connect outside of the firewalls, you have some additional care that you need to add. And the reason I separate the two is there's a lot of very positive outcomes that you can get through the Internet of Things. For example, we can just about eliminate non-productive time, which is unplanned downtime, on the big assets that GE provides to our customers by bringing the reliability data up to cloud infrastructure, running a set of analytics against it, predicting failures, and allowing people to have planned times when they can address those problems. This literally saves people millions of dollars in a typical year. And we'll publish catches of the week, every week, the number of saves that we're making to our customer base. Now, we can do that without having to completely change out the control systems that are in place and have been in place, because we haven't made the situation any worse. And this is where I agree with Xavier. If you're going to bring the data into a different cloud infrastructure, you need some type of a mechanism to do that that is invisible to the internet, that has no open ports, that has the ability to understand where it's sending information to, but do it in a secure, authenticated way and not have attack vectors from the outside. And we're very capable of doing that and have done it for quite a few years. On the control system side, I think that's going to take a little bit longer to put in place across all of our industries. Why? Because it's one, it's a kind of conservative industry. Two, people don't change out their control systems, every day. And three, the technologies are really just starting to emerge that make that possible. And we're doing the same thing within our controls, PLC, DCS type systems, making sure that the attack vectors around, is it running the right program, the program that we expect it to run? Is that actually what's there? How can we virtualize the control system and have a security watchdog that's part of the hardware that's sitting on top of it? How do we make sure that we're making use of trusted modules so that we can have certificates that exchange between consumers of the data and the suppliers of the data, and making sure that really any application that's connected to that type of information is actually an authorized application to connect to it. And so, I think that will emerge over time, and it'll make our plants more and more secure, independent of the Internet of Things. But, what I would hate to do is recommend to everybody to wait until that's in place before they start to make use of the great capabilities that are starting to emerge in some of these cloud-based systems. Certainly, we're not waiting. We're doing both at the same time. We acquired a company called WorldTech, which is a security expert, to shore up our overall systems. But we've been doing these remote monitoring and diagnostics, and now we're starting to do operational optimization applications at the same time, and do it in a way that our own company is making sure is secure, because we're just as concerned about that within GE as well as many of our customers. So I think you have to look at both problems and solve them, but they don't have to be serial in terms of the solve.
Are there any questions? Yes, go ahead. Come up to the microphone. But we need you to come up to, I'm sorry you have to come up to the microphone, but it's the only, the session's being videotaped, and the feed for the sound comes through the microphones. So if you just talk, we won't record. So please.
Lee Richard. Is that on?
Is that on?
Is it on?
Yep, we can hear you.
All right. Lee Richard, Owens Corning. My question's a little bit long, so bear with me. I don't know how to aptly think about IIoT, right? Because I don't know what it is. So the parallel I would make is to safety. Owens Corning in general, safety is really a prerogative, and they encourage employees to take safety home. So over the years, the way I look at a parallel to Internet of Things safety is, Internet of Things security is how I treat safety. I have kids, and when they were little, my perimeter defense was the house, right? They didn't move. They didn't do much. They didn't walk. I didn't need to worry about safety shoes and tripping hazards or anything like that. They were little. So my perimeter defense was my house. As they grew up, now they go outside, they go to events, school, church, whatever. And now my perimeter is much larger. Now they need to go by car somewhere, they walk. I'm worried about the shoes, right? Eventually, they'll be older and fly somewhere. Now I'm worried about what kind of planes they're traveling on, taxis in foreign countries, foreign cities, etc. So little by little, from a safety standpoint, I'm more and more concerned. And the way to handle it for me is really to embed safety by design thinking into them. Is it something similar here where really federation is the key? Just like you have authentication to log onto a system, but then you've got federated authentication to log on to systems from outside, multiple systems, where you're doing a lot of federation. Is it apt to think of security in that same way, federated cybersecurity, where it's not just devices, but it's the transmission between devices, it's the mobile device is going to access the data, it's the things that's going to supply it, and it's the overall network, cellular or otherwise, that these things are transmitting through. Is that a good parallel to look at it? Because I heard a number of you talk about device security, but isn't it a lot larger as well? And then also if you could talk about this concept of federated cybersecurity. Thanks.
Does anyone want to respond to that?
I'll say a couple words and pass it over. Xavier. Absolutely agree with you. This is not just a device problem. This is not just a cell phone network problem. This is a system level problem. Our basic assumption within GE is that the future of the control system, all control systems, will have a cloud and an edge component. And the cloud brings that elastic compute and elastic storage environment where you can build sort of that ambient intelligence that makes you more productive in your control system on the plant. And why does that happen? Because as you collect and organize the world's industrial data, you can start to tease out the recommendations that are based on experience so that people can make better day-to-day decisions. In that cloud edge environment, where a portion of the recommendations are coming from the cloud and a lot of the local control is happening at the plant, your interfaces are looking at both simultaneously. And you have to be securely authenticated both within the cloud, whether it's public or private, and in your control system. And to do that, you have to have some very extensive secure-by-design principles in place.
In
so
the
you're
device?
absolutely both in the device, between the device and the clients, between the clients and whatever gateways or other mechanisms you use to the cloud, and even up into the cloud. And it's a system-level problem, and it has to work together. So completely agree with you.
Yeah, I would totally agree. I'd add, there's two ways of looking at the problem. One is to say that every device, every user, every plant, everything that's connected has to prove trust. The other way to look at it is say, I'm just going to assume everyone's untrusted. And if you just make the assumption for a moment that every device is connected or everyone's trying to connect is untrusted, then you can separate your ICS from your data. And now you create an isolation. So that I believe the key is to isolate all the connecting devices, isolate all the users, and isolate the plants, ICS. So that way there is no direct attack surface other than, if you attack one device, you do not get control of the SCADA system. It won't happen.
Anybody else want to?
Yeah, I don't have anything to add to that. I just want
To talk.
No,
Sorry.
I got your perimeter analogy with your kids, but when they were young, what was your anomaly detection system?
How many kids do you have? 2? I have 7. It's a big problem.
See, the attack surface is exploding.
That's right.
It's exponential. Yeah.
I don't know what else to say. What's that? What's that?
Thing one, thing
Thing one and
Thing 1 and
two.
thing 2? That's thing 7, thing. I'm not sure what you mean by federated cybersecurity. Can you expand? What do you mean by federated? I'm thinking Star Wars right now.
Yeah, no, just to make the parallel to federated authentication, just the idea that it's not just the single system that you're trying to get into or the single device that you're trying to get into secure, et cetera, but the whole ecosystem that at the end of the day needs to be secure.
Mm-hmm. Yeah. Yeah, this is really, it's kind of hard to have this really good dialogue in this because, I've sat down with some of you under NDA, some of you not, but just to describe the complexity of a system, a holistic cybersecurity system, takes many, many hours, but it is a very, very holistic, complicated issue that you want to simplify and make it invisible to the user. But it does require a fairly sophisticated authentication. So again, if you have a deep root of trust in the edge devices, the whole myriad of them, and you have then an authentication process and a key management process. So you have these keys that allow you, these crypto keys that allow you to say, to allow some kind of a transaction. Then the key management process to, for instance, in the case of when the technology that we've built, the microcontroller has a series of keys that are secure in protected memory, crypto keys, and then the device lifecycle management system authenticates the controller, the microcontroller, to the board, authenticates the board to the module, authenticates the module to the system, authenticates the code to the module, and authenticates transactions and applications to the system. So it's very much a layered system, and it's pretty complicated to describe, but once it's all in place, it needs to be transparent, So I don't know how else to add value to you in that, but
Did you want to say anything, Bill? No? Let me follow up with all the comments here. You know, because I came from it, the secure device, secure communications. I think what most people expressed here is more a secure, and I'll give Lior credit for this term, he mentioned it to me earlier, secure architecture kind of a thing, meaning all of it has to be secure. But let me just throw one thing back at you that I wonder about. You know, today, and particularly if you think from the control system paradigm, it's a controlled environment. I mean, it's not, I don't mean secure perimeter, I'm not saying that, but it's something you know exactly what's there, somebody can engineer it, someone can say this software belongs in this, or this device communicates with that, stuff like that. So it's a very engineered, controlled kind of situation, okay? And I mean, to me, securing that is probably no different than securing a control system today. It's just that maybe you have to deal with other issues because you're going out on public lines and encryption, things like that. But I just have this vision, and maybe it's wrong, probably, but that it could end up being a much more fluid kind of environment. And an example of what I mean, for example, I mean, I do think that people will have devices, whatever they are. Maybe they're embedded controllers in some type of a piece of equipment that's important to you. At the gas station, all right? That tank, whatever the fuel tank the control system was, all right? Now, I picture in the future that somebody's going to go up to that and maintain it by going up with their laptop, and they're going to connect through Wi-Fi or something like that. Now, that's not something that you maybe you could sit down and consider that one situation, but I think there's a lot more device-to-device communications and a lot more fluidity in the architecture. And so I don't think, so my point is simply that it's one thing to sit there and say, I'm going to think of all the things that can go wrong, all these are my pieces, how do I secure all of them as an engineer? I'm an engineer myself. But it's another thing when you say, I don't know what's going to be in there, I don't know what's going to connect to what, I don't know how it's going to connect. In that, for me, it falls back to say, the only thing I can do is make sure that each of those pieces has all the security it needs itself to take care of itself. You know, it's more of the extreme case of, like today I made the point about the control system. I'm sorry. Oh, I didn't even see you there. I apologize. But in the control system, you know, where I made the comment about a lot of people today in ICS cybersecurity, you're taking advantage of knowing the topology of the network you are in and the security that's above you. I mean, I talk to lots of people, you know, it's the defense in layers. Well, in this case, the networking kind of layers. You know, that I have firewalls here and this one, so what can get down here, so I don't need that security there. This is more where you can't make those assumptions because you don't know what's going to happen. And I'm just wondering if maybe I just am way off my base, that the world's never going to be like that, in which case I guess I don't have to worry about it, or if I do, what do I need to do for a device to make sure that it's secure and that the networking is secure? Now, maybe you don't want to answer that question because maybe it's off base. I don't know. Does anybody want to comment on that, or are you just going to leave that one go?
Actually, my question is very much around that.
Oh, and then please, you ask your question.
So basically, does it work?
Can you turn that? Oh.
Okay. Hey, my name is Michael. If I look at kind of analogy, and every analogy fails, but so if you have a vessel and you want to prove it's watertight, what do? You put water in it, put it under pressure, no water leaks out, so you're good to go. So same thing here. How do you know that your Internet of Things, the connectivity is secure? And so what I've heard until now, it's only secure until it's proven unsecure. But is there kind of a smarter way that you kind of, say, well, if you follow this protocol or if you do this, then you know for sure that it is okay, like 99.9997. So do you have an advice how we can?
I would add a couple of things there. From a hardware standpoint, now I have a background in wireless, so I understand a bit of the challenges from when it comes to securing a mobile gateway, for instance. Very few people realize that today you can actually send an SMS to a mobile gateway, and it'll actually wake up and go and load some software. Very strange as it may seem, but it was designed for the reason that they needed to be able to have remote access to the device. And the carrier's position, and if there's any carriers in here, I apologize, is that our network is secure. You can never get on my network, so I'm going to secure it using my network. Meanwhile, if I send it an SMS, I can tell it to go to any network. I don't know if there's a certification band or if there's a way to certify that a device is secure, but if you just follow the simple rules. One, don't open any inbound firewall ports. The device should have a firewall at best. If it doesn't have a firewall, then there should be no way to remote control it, i.e. you can't get into the device, period. And two, turn off any remote monitoring capabilities on it, or three. And four, if you have a software partner who says that they can remote monitor it, you need to test how they're going to get into it. Because if you're going to get into that device, that means somebody else can get in as well.
Lior.
Can I jump in quickly?
Yep.
I think we're going to fail if we try to treat this as one problem where everything that we classify as industrial Internet of Things is going to have the same level of security and the same level of certification, accreditation, whatever you want. I mean, you can tie this, if you look back at the financial industry, they accept what most people would consider a sizable level of fraud because it's an acceptable level of fraud to them, you know, whether it's 3% or 2% or 4%, but they do this, and a lot of what we classify as industrial Internet of Things will have a pretty minor impact on people's lives if it is compromised. And I doubt we'll be securing those things as much as we're securing some of the factories and mines and other things that could have big safety, big financial impact. So I think it's dangerous for us to say we need a solution that we're going to put in every product that'll be the same. I mean, we actually have some experience with this as well with the smart meters that have gone out. I mean, there's a big difference between a smart meter that allows remote disconnect that could potentially knock out the power to a lot of places, and a smart meter that's just getting readings where you've got back-end algorithms that can, you know, detect when a reading is out of whack and automatically bill someone a projected reading until it can actually be read. So I guess I don't have the answer to your question, but I guess the question bothers me a little bit if we start looking at it as we need a way of securing everything in the industrial Internet of Things with the same types of security primitives.
Yeah, I too have criticism about your question.
Thank you.
I think, first of all, that you cannot secure anything, period, and say you are secure. It's a bit different. You know, you gave the example of how do I know if it's airtight, but when you are thinking of it from the same example from a let's call it a cybersecurity issue point of view, so you're not just asking if it's airtight. You're asking, okay, but now let's say that I tested it and now somebody intentionally starts to poke holes in the boat or starts to, I don't know, do bad things. And what happens if I crash into an iceberg? And what happens, you know, these are the questions that your test that said I'm secure or I'm, you know, safe didn't answer. And you can never answer those and say, okay, I am secure. It's a process that you always need to reevaluate and move forward and, you know, assess new risks and learn from those that happened, things that happen to others and things that happen to you. You cannot be, you know, secure and move on to other issues. It doesn't happen.
Makes sense what you say.
Yeah.
Okay.
I would tend to agree with that you know, there's not one solution that fits all. And just, you know, a couple of examples. I think we also, like yours, I felt that the VPN-based solution has too many pitfalls. But it was, you know, the best of the industry for some period of time. And we've started to replace those throughout with, you know, connectivity that doesn't involve a VPN because it's a more secure approach. Now, when it comes to the SCADA systems, most SCADA systems, any client can connect to the SCADA system. And once a client is connected, it can do all kinds of damage. Understand that's an attack from within, but Stuxnet and some of these attack vectors were from within, not from without. And so, we're moving to an OPC UA-based architecture with a global discovery server that exchanges certificates between the client and the servers to make sure that that's an authenticated and a secure connection between the two. Now, is that guaranteed to be safe in all cases? I can't mathematically prove that, but it's significantly better than what we have today and will evolve from that kind of endpoint. When it gets down to the controls, the same kind of thing. Those have been wide open for many, many years. But now that we can put, the trusted control modules on there, and we can store keys, and we can have a secure, authenticated connection to it, and make sure that when they boot up the program that's running, that's significantly better than it was before. And as we understand the new attack vectors that emerge, we'll continue to try to address those. So I don't think this ever ends. As good as we get, sort of the bad elements that are out there are trying to stay a step ahead of us.
Please.
Hello, I'm Kevin Davenport with Cisco. Real time is always a term that's, I don't know if it's overused, but it's commonly used in the industry. And with security, there's always some overhead associated with security. So outside of just the perimeter strategy, one of the holes I see is those mission critical applications or mission critical devices. Have you guys put any thoughts around addressing those holes that might be accessed because people just know that mission critical apps aren't as protected or involved? That's a basic question.
I'll just say something quick on that. I think, within the plant network, we're not sure we can stop all the attack vectors, but we can make the applications much more resilient to different types of attacks. And so a lot of our work is, yes, to try to stop it, but also to recover from it and continue with normal operations. And we really like some of the things that are coming out in terms of the time synchronous networks, where you can guarantee a slice of time regardless of what else is going on in the network, because there's certain attack vectors that try to consume the entire network, and that affect your real-time systems. And so those are some of the things that we're exploring to try to bring to the standard control system, so it's a lot more resilient than it has been.
I would say in terms of the point of real-time, real-time's not new for industrial automation, and it certainly isn't new for the internet. I mean, today, if you take a look at ping times or travel times, what we're seeing today versus 5 years ago, I don't think there's a place in the country where we can't get ping times below 36 milliseconds. So I would tell you that from a risk perspective, I think that's going down because the networks are getting faster, and as we move to IPv6, they're going to get even faster than that. And it's just a matter of time where we're going to be at a point where real time will be will be in sub-second rates. Even today, I mean, when you go over to the booth and take a look at people, there's a bunch of us who are using air cards as wireless for internet for our booths. I mean, I know we're experiencing around 65 millisecond run rates, so not bad.
Kevin, what do you consider real time for mission critical? What is the timeline you're thinking?
Yeah, I was thinking, sub-millisecond, 10 milliseconds. Well, a lot of motion control applications and such, not the broad big data apps with mission critical, mostly motion control.
So I could show you, but by using hardware accelerators, crypto acceleration, math acceleration in silicon, it really solves the problem. We do all real-time crypto and encrypt the communications and the data, and for all I/O within a system is 1 millisecond, deterministic 1 millisecond. So that's within your timeline, I think. So with the technology today, you don't need to compromise. And that's all I say.
Yes, please.
Keith Campbell, Packaging World. I want to get to the practicality of what we're talking about. I mean, this thing gets a software update at least every day. And you mentioned the need to move from VPN to other things. And, you know, we have tens, if not hundreds of thousands of devices yet in the plants that are still running XP. So can we practically have a change management program and a product life cycle that we can live with and do the things that we're saying we know theoretically we can do and practically we can do, but can we live with the consequences?
Yeah.
He's got more plans than me.
So, I mean, it's a great question, and it's a really critical question. And I think, you know, the industrial internet has to bring some of the technologies that you see in the consumer internet and bring them to bear in the industrial world in a way that doesn't compromise the security of your entire network. And, you know, the way the update works on a PC, nobody's pushing that down from the cloud. Your PC is waking up, and it's actually going out and asking to see if there's anything new for it. And if so, then it forms a secure connection and brings something down to it. And, you know, we see that's possible in the industrial world, maybe to update firmware, maybe to update PLC logic, but very carefully based on customer policies, and sometimes based on the fact that there's two people at each ends of the curve, you know, with somebody actually turning a dial for some period of time when that happens. And so we think, you know, the benefit of being able to put updates out and make them available to a fleet of equipment that's out there is going to happen. You know, whether we lead it or somebody else leads it, it is going to happen. But it has to be done very carefully, and it has to be done according to the policies, just like any other IT infrastructure requires a set of policies before it'll accept updates. And I think the the convergence of IT and OT, this is one of the places that it's absolutely going to happen in the industrial space.
Dale, did you?
Yeah, and I think this ties into the previous question too. And you had that chart where you showed IT and OT separated, and we hear about the differences, but so often we're comparing our DCS, our SCADA, our systems that are running very expensive plants or mission critical systems to desktop management on the corporate network. And of course, those are incredibly different, and they have different user communities, different requirements. When you compare OT to mission critical IT, where you can determine how much it costs for every minute of downtime, you know, on some of these e-commerce apps and things like that, they're actually, the way that you manage those are actually quite similar. And the biggest difference is that OT has accepted a level of insecurity and fragility that would never be accepted in mission critical IT. So when you look at these updates and other things, you're going to see where you have similar requirements in OT that are in mission critical IT, they'll be updated the same way. Where you have lesser requirements for uptime and integrity and availability, you'll see them pushed out and more automated. And I think you're right. It is going to, the best solution is going to be to give the owner operator some ability to control how this happens.
Do you have a question? Sure.
Pete Anderlo with Kimberly-Clark Corporation. As I think about systems and the different levels of security, that I think of the platforms, I think of the users, I think of the data. What are the critical components that people that have to implement systems, what are the tools that we have to think about? You mentioned firewalls. What are those other tools that we're going to have to dig into and be prepared to have in place so that the squishy inside of our control systems are protected?
Well, Sid asked us not to be too selfish, but you asked for it. So.
No, you're just taking advantage of it. Go ahead.
Yeah, no, I planted that question, by the way.
Oh.
Well, you know, there are many products and new technologies today. The technology that Waterfall develops, and one of our flagship technologies is the unidirectional security gateways, which allows you to share information or to, in a sense, provide access to data without providing access to your networks. And in most cases, and in most of the use cases that we're described here, it provides you, I think, the best solution possible, providing the whole need, providing in full the need for either remote monitoring or having remote access to information, while keeping your network actually detached and inaccessible. So this is an example to a technology that is being adopted quite widely and in a growing rate when designing new systems or when putting security in existing systems.
Anybody else?
Yeah, I mean, a couple of comments here. I think, you start with the outcomes that you're after. And so why is the Internet of Things interesting in the first place? And, a lot of people just start with basic reliability programs. I have very big, expensive equipment that has catastrophic impact if it fails in production. Can I start just by predicting when those are going to happen so I can plan the maintenance instead? That's not a two-way problem. That's a one-way data problem. And so, technologies like what Waterfall provides, where you can have the data sort of replicated and separated from the plant network, I mean, those work very well and they're very secure. Technologies like we have that then analyze that and provide you information back, maybe in the form of a phone call, maybe in the form of some cases that come to you. Those are very secure and have limited to really no impact on your control system. I think when you want to start to go to the next level, where maybe some process optimization is happening between what's going on in a cloud-based infrastructure and on site, you have to have some additional care. And a lot of our customers start off with just maybe we're monitoring their process loops, and there's 5,000 of them, so they can't keep track of them themselves, but we can tell them which ones are drifting, which ones aren't, and they can manually go and adjust them. I think when it comes to actually doing some process optimization, we prefer still today to put that on site and to integrate it in with the supervisory systems, as opposed to putting that kind of thing in the cloud where it might be a two-way action. And I think that's really the state of the maturity of the industry today is when it comes to control, we like to keep that within the plant's network. When it comes to analyzing the data and providing feedback, we're okay with doing that offsite.
I'd like to add one thing is, and we saw this with the snapshot dongle, was if you're going to deploy something in the field to your customers, make sure you have a secure update capability, because essentially anyone can reflash that device. So there's really no way to ever get the integrity of that device back. Sure, the vendor can upload new code, but so can anyone else. So if you're going to have something that's relatively low cost and deployed in large numbers, having a secure update capability would be pretty high on my list.
And question, Peter, when you say the squishy inside, you mean for your existing sites, your existing legacy installations? Is that what you mean?
All the systems that are in Secure-by-Design.
Yeah. Mm-hmm. I can't really respond to that because I don't have a squishy inside. But it's a problem. Yeah.
Pete, you bring a good point. There are millions of companies out there that are in the same position as you are. You're not the only one. Everyone's got that squishy inside that's dealing with a DCS or dealing with a control system that's not new. And so you got a choice. You can replace the control system, which you probably don't have the budget for, or you can try to put a shell and to control it. I think best practices, one of the things that IoT will do from a promise standpoint is provide you better security layers. That's what it should do. But I think best practices, I mean, everyone should have a firewall, there's no question. If anybody here says that they're not internet connected plant, we know they're lying because they're pushing data out through the internet somehow, some way. I would tell you, put a proxy in. Don't question it, just put one in. If you're really concerned, put a DMZ zone in. It's not a big deal. Most modern proxies can move data. There's not a problem. It'll give you the isolation. And I think IoT will provide you a solution to connect your older plants. It has to, because we as vendors can't make the assumption that you have to change your entire control system. So we're going to have to work with what you've got. Now, some of these people may disagree with me.
No, absolutely.
But we're gonna have to, we have to adapt to old plants. We have no choice.
I guess I would disagree when you say old plants, because you look at the plants that have been deployed, the DCS and SCADA systems deployed in the last year, or even being deployed now, they still are insecure by design. So that's one of the things when people, and we heard this from General Tuhill this morning, he talked, well, we have this problem of all these old legacy systems that we're gonna have to live with for a year. Let's be honest, we're still putting these systems in.
Right.
And it's going to be, we need to start addressing that.
Absolutely correct. Let me pull the words out, not old plant, but insecure plants.
Just buy my stuff.
Let me ask,
No.
go ahead, Albert.
There's the ICS cert. There's the ICS cert tip 015-022-01. It's a great best practices, fantastic document. I'd recommend it.
Yeah, so I'll add a couple things to the ICS cert. And this really goes at sort of the maturity. I mean, we're a SCADA provider, so we understand what's there. And I think about the maturity that we've had to go through over the last few years with the Prophecy SCADA systems. Well, we started off by being what I would say is very good at reacting when a threat was detected. And, that only gets you so far. I think, you have to get to the next level where you're watching the security changes that come from the vendors like Microsoft and the other content, and within days, you've actually got the next releases that are out there. So if you don't have, sort of that upgrade mindset so that you can constantly take advantage of the new capabilities to prevent threats, you're missing something. Then I think we really progressed to the point where, well, we started attacking ourselves. And, how can we get ahead of the curve and really start to, there's a set of known attack vectors that people use, and we'll try them all on ourselves. And we work with ICS CERT and actually try to address those and put those kind of capabilities into the product. Then you go to the next level, you start to pay experts to come in and attack you and, try to break your stuff and make it as resilient as possible. Is it perfect? No, probably not. I would hate to say that because I'll get another 100 people that are going to try and break it. But the progression has been pretty significant. And if you're current on your systems and you've kept them sort of at the latest levels, they're significantly better than they were 5, 3, even 10 years ago, certainly. So I would definitely recommend, just like any other software systems, to try to keep them current and try to get the latest updates and make sure that you've got the latest security fixes.
Okay, we're running out of time. I've got one last question then. I'm going to follow up on something Dell said earlier. They're insecure by design, and then you made the follow-up comment that the systems sold last year are still insecure by design. And I'm assuming, and you know better than I, but I'm assuming that companies like GE, and I'm not picking on GE, but the ICS companies are all shipping systems today that probably follow the recommendations of a 62443. I think that, I may be wrong, but I believe that's true from my discussions with them. So, they're putting in firewalls, they're zoning them, they're putting in DMZs, they're doing all that kind of stuff. And you're saying they're still insecure by design, and I think I understand what you mean. So my question is, and I think maybe your question, what more needs to be done to make them secure? Because if he doesn't want to go and buy, the one issue is the fact you have systems, but the other one is, okay, you get somebody in your company say, fine, we're going to replace it. You don't want to replace it with one that's insecure by design because then you lose your job. So what more would you do? Yes, that.
Can I
know
answer
you buy
that
yours.
one?
I know it's buy yours, Albert. No, I knew that, and I'm not joking. I'm serious.
No, so am I. Yeah. You kind of have to start from scratch because it's a very different paradigm, right? And you need, of course, secure microcontrollers. You need you need FIPS, so your modules have to be anti-tamper. You can't get there from here using plastic. Plastic doesn't work because you can't get the active anti-tamper. You can't seal the modules the way you want to. You have to have a secure OS. So in this case, we're using Integrity from Green Hills, which has the EAL6 plus certification. It goes on and on. You have to have, everything has to be secure. You have to have a key management technology, a key management infrastructure, and you have to secure the entire supply chain. So you secure the chips, you secure the module, you have to secure the ODM, or the contract manufacturer. The factory itself has to be secure. And so it's pretty comprehensive, but it can be done.
I think what I would add, and kind of what we've been harping on for a while, is the underlying protocol has to have authentication of the source and content. So, you know, if you look at the Profi standards, they haven't even started adding authentication. ODVA has just started a group to try to add it to Ethernet IP. There's some DMP3 security. A lot of these protocols, you can even upload ladder logic and upload firmware with no authentication. And I think until we get that in place, you will have insecure by design systems. So there's been a lot of progress, and I'd say the HMI, engineering workstation, server apps, some of those companies are, you know, 5 years or more into their security development lifecycle and have new features and much more well-designed code. But until we solve this protocol thing, this is why the industrial Internet of Things is so dangerous, is if we allow remote access from untrusted devices anywhere into these insecure by design systems, we're really opening ourselves up to a much bigger risk than we face today. And the risk today is kind of scary, just with spear phishing and normal type attacks.
You gonna skip that one, Leo?
Well, I think the problem is actually a lot deeper than that. I actually think from a SCADA perspective, we need to actually change the direction of the data. We have a master-slave relationship today where the master asks for the data. I don't think we should be asking anymore. We should just, the sensors, everything on the network should be publishing it, and you should subscribe to it. And if you do that, then you change the whole paradigm of how the system works, and all of a sudden now you can put in layers of security and certificates to now turn around and create a secured by design industrial system. So change the paradigm around.
Rich, tell them what you're going to do to solve your, or
Well,
address your systems.
You know, I mentioned before the OPC UA protocol, and we see a lot of promises that as becoming a more secure infrastructure for the industrial world. It certainly has been thought through from a security standpoint. It's no longer based on the Microsoft technology, so it'll work across different systems. And, you know, it requires you to have a key-based connection between the two endpoints, and it's an encrypted connection. And, you know, we're going so far as to actually putting that on the controllers themselves, so that they can publish their data and make it available to the
controller being
supervisor.
a PLC?
A
or-
PLC, yeah, right on the PLC. So now you've got a secure protocol on the PLC that's exposing the data to the different systems, and you know, we think that that's a pretty good path right now to go through. But we also are doing a lot of work on the core PLC itself, because to some points that were already made, you know, there's passwords that people could get into. The protocols like Profinet are not necessarily secure. Modbus is even worse. I mean, by moving to, you know, the more robust protocols, we think that that's definitely a step in the right direction. And we do like the publish subscribe type environment, because you can have some better success, but you still have to worry about the set points, because a lot of times the SCADA system is actually, you know, pushing information back down to the control. Either it's a recipe or, you know, changing some values of some of the loops. So it's a combination of things that's going to require. OPC UA, then, we go beyond just the controllers to the HMI. We go to the HMI clients, to the historians, and to everything else. Now you know, through policies, can control the different endpoints and who can connect to who. You could choose, you know, to turn some of that off, but that's not what we would advise. We would advise to make sure that you know which applications are producing data, which applications are consuming data, and that you have good control over that. One last thing I'll just add. You know, the global discovery server, I don't know if that's a concept that people know very much about, but that's a OPC UA component that we've just released. And what that does is it actually manages the certificates. Because if the certificate management is not somewhat transparent, nobody will use it, because certificates are a pain to get right between the two sides of things. The global discovery server is a component of OPC UA that you can use for two purposes. One, to exchange certificates between the two sides and make sure that they're authenticated and based on the policies at the site, but then also to discover the data that's actually out there that you want to subscribe to. So that's a very good concept that's part of the OPC way specification.
Okay, well, I want to thank the panel. I hope you join me in thanking the panel. Very good discussion.